Dear colleagues, the results of the research are offered to your attention on model investigations into assessing optimal power consumption modes for major pump stations of iron ore underground mines. Mining enterprises are classified as electricity capacity industries.
This factor, when electricity accounts for about 90% of total energy consumption of enterprises and more than 30% of the cost complex, is a basic component of a significant existing level and constant growth of energy capacity of mining, which negatively affects the economy of mining enterprises and their global competitiveness raw materials market.
In recent years, there has been a debate in the world with the possibility of building on the basis of the main water pumping systems of hydroelectric power station.
In the process of solving the problem of improving the energy efficiency of water pumping system by building them on the basis of hydroelectric power station, there is a problem of substantiation and development of logistics to achieve energy efficiency potential of these complexes in the format of consumer, regulator, producer in hours.
To develop an algorithm for controlling the operation of the main pumping systems in a synergistic version of their structure, it is necessary to establish the factors and their levels of impact on the energy of the complex.
Slide 2 presents the purpose of studying the levels of electricity efficiency of the main water pumping systems of iron ore mines, as a function of hourly daily tariffs for electricity consumption and developing a methodology for analyzing the impact of electric power of pumps on electricity consumption, which is based on multifactor regression.
In the process of analysis of the distribution of levels of electricity consumption between energy capacity consumers of iron ore mines, the individuality of each enterprise in terms of electricity consumption is proved. Slide 3 shows the ranges of fluctuations in the levels of electricity consumption by type of mine consumers.
The analysis of ways of increase of electric power efficiency of functioning of pumping station of the mining enterprises in the conditions of underground extraction of minerals is generalized, probably by
optimization of the technology of their functioning pumping day with the transfer of the maximum of possible work on water pumping to areas of economic level of payment per due of electricity consumed. Creation on their basis of revolving hydraulic units. The latter will allow mining companies to produce their own electricity. In this case, the algorithm of drainage systems is as follows. In the economic hours of the day, from the levels of payment, water is pumped from the mine to the surface in the appropriate reservoirs, and in uneconomical, on the contrary, part of the water from these storages is pumped into the mine in the mode of electricity generation. At the same time, it will be necessary to additionally, on the basis of the analysis, refine the structure of drainage installations in the mode of electricity generation and modernize the pumping units themselves to be able to function both in the mode of water pumping and in the reverse mode of electricity generation. To analyze this process, it is necessary to develop mathematical models for analysis and development of areas of theoretical achievements. This is possible through the introduction of modern systems approaches and mathematical and statistical methods. The dynamics of the levels of electricity consumption by mines over the years has been studied, and it has been found that they change insignificantly and, rather, tend to be stable.
The analysis of the factor space of electricity consumption by pumping units allowed to determine the main influencing factors in the dynamics of individual iron ore mines, shown in slide 5. They include the depth of the mine, water inflow, number of pumps, pump capacity.
Using the main factors of influence, we propose the following formalization of electricity consumption by pumping systems.
We propose, in accordance with the system of research, the distribution into control components, which we propose to include horizon, the number of running pumps at the ITH stage of pumping, water inflow at the TH stage of pumping, and the disturbing factor power.
In accordance with the purpose and objectives of the research, we propose the following statement of the problem of minimizing the cost of electricity consumption when regulating the load of water pumping systems. The solution of such a problem involves in-depth preliminary analytical analysis. Z-scaling was used for comparative analysis in order to have a single system of interpretation of indicators. The presented article presents the results of our research on the Batkivshina mine. Slide 8 shows the dynamics of the cost of electricity in relation to daily plan tariffs. Summarizing the initial data, we have a total excess of the daily cost of electricity at a 3-zone tariff compared to 2-zone. That is, it is advisable to conduct a multifactor study of electricity consumption as the most effective method of determining the impact of these factors on the cost of electricity consumption. The processing of the original data was processed using Microsoft Excel. Slide 9 presents our multifactor model for the cost of electricity consumption. As a result of multiple correlation analysis, it is shown that the variable x1 can be linearly expressed in terms of x2, i.e. the variable x1 can be excluded from the input variables. The coefficient of determination was 0.824 and Fisher's criterion was 14.1. The tabular value of the Fisher test is 4.07. Thus, we can note the adequacy of the obtained model. Based on the simulation results for specific conditions of the Batkivshina mine, it seems logical to conclude that the influence of pump power on the value of electricity is positive, i.e. causes an increase in cost. The value of the elasticity of the cost of electricity by the power of the pumps is calculated according to the formula presented on slide 10. Accordingly, the graph of the elasticity of the cost of electricity by the power of the pumps of the Batkivshina mine is presented. The analysis of the graph shows that the elasticity of the cost of electricity in terms of pump capacity is positive and grows monotonically. Thus, the developed method of economic and statistical analysis allows not only to qualitatively assess using a critical value of the cost of electricity by pump power, but also the impact on the cost of electricity. Slide 11 summarizes the findings of the study, which are as follows. 1. The suggested methods involve innovative approaches to evaluating power costs for operating pump stations of iron or underground mines. 2. Application of modern it enables digital methods of processing statistic data of power consumption indices including consumed electricity costs, the water inflow level, the mining depth, the number of pumps and capacity of motors. 3. After synthesizing mathematical models as complex objects, the authors assess the influence of pump capacity on power consumption and conduct numerical analysis by using the elasticity factor to determine dependency of power costs on the capacity index of pump motors. This approach is worth applying in practice to forming the strategy of providing energy efficiency with time-of-day electricity rates. The report is over. Thank you.